Underwater volcanoes aren't just found in movies, they're real, and they can be found throughout our oceans. In fact, there are over 450 known underwater volcanoes around the world. But this raises a question. What happens if a volcano erupts under the water? There are plenty of places on Earth where boiling hot water meets the ocean. This includes areas known as hydrothermal vents, which form when seawater seeps into the cracks of the Earth's crust and is superheated by magma chambers before being forced back up to the sea floor. Despite these environments looking like something straight out of hell, life still exists there. But how exactly do organisms survive in such extreme conditions? Keep watching to find out what lives inside boiling hot water. It might seem obvious that anything living would want to stay as far away from boiling hot water as possible. After all, we humans know that if you get too close to boiling water, you could burn yourself badly. But for many creatures living in hydrothermal vents, not only is the water boiling, it's also toxic. It contains chemicals that would kill most living things, including us. For example, these waters contain high levels of hydrogen sulfide. You may recognize this compound from rotten eggs. It's released by volcanoes in the form of volcanic gas and is one of the main contributors to the awful smell of a volcano. The gas is also poisonous and can cause respiratory problems and even death in humans. Despite the danger posed by the chemicals contained within them, many creatures have adapted to thrive in these conditions. Take the scaly foot snail, for example. It lives near hydrothermal vents in the Indian Ocean and has been dubbed a super snail due to its ability to survive the crushing pressures, scalding temperatures and poisonous chemicals of the deep-sea vents. But how does this snail and other organisms survive in such harsh conditions? Well, first of all, life at the bottom of the ocean isn't the same as life on land. There's no oxygen down there, so organisms living near hydrothermal vents can't breathe in the same way we do. Instead, the energy needed by animals living near these vents comes from bacteria. These bacteria use chemosynthesis rather than photosynthesis to make their own food. Like plants on land, they convert inorganic matter into organic matter, but instead of sunlight, they use chemicals for energy. This means that animals can survive in the absence of sunlight and feed off the bacteria that live in the most extreme environments. Take the scaly foot snail. It feeds off sulfur-oxidizing bacteria that grow on top of it. These bacteria get their energy from compounds found in volcanic vents, which makes them the perfect food source for the snail. So while these environments may look uninhabitable to us, they're actually quite hospitable to the organisms that live there. And this includes some that we share a surprising amount of DNA with. In 2020, researchers collected samples of life from the South Mariana Islands and the Mariana Trench. They found an abundance of crustaceans called amphipods. These crustaceans looked similar to small crabs or lobsters and seemed to thrive in the harsh environment. But what really shocked scientists was what they found inside these creatures. Scientists took tissue samples from the amphipods and compared the DNA to that of other crustaceans. They found that the DNA of these deep-sea dwellers was extremely similar to that of crabs, lobsters, and shrimp found much closer to the surface of the water. Scientists think that this shows that these amphipods evolved very recently from shallow water crustaceans. This means that despite the distance and extreme environment, these creatures likely made their way to the bottom of the ocean relatively recently. But why did they go there? Well, it's simple. Food. At the bottom of the ocean, there is a constant supply of organic carbon. This is the main component of most foods and is essential for life as we know it. While there is less organic carbon in deep waters than in shallower regions, there is still enough to sustain life. On top of that, the bacteria living in hydrothermal vents convert chemicals into food, providing yet another source of nutrients for the animals that eat them. So while the conditions are extreme, there's still enough available food to support populations of certain organisms. Of course, that's easier said than done because there's also the added pressure of living at the bottom of the ocean. As you go deeper and deeper into the ocean, the pressure increases drastically. This is due to the weight of the water above pressing down on those below. So at the bottom of the ocean, the pressure is hundreds or even thousands of times greater than what we experience at the surface. For a human, this kind of pressure could be enough to crush your bones and rupture your organs, but the creatures living near hydrothermal vents are more than capable of handling it. Take the snail we mentioned earlier, the scaly foot snail. Its shell is incredibly strong and can withstand the crushing pressure of the deep sea. It also has a muscular foot that allows it to move around on the seafloor without being crushed. So even though the environment looks hostile to life, it's not. Creatures have adapted to survive in almost every environment on Earth, including boiling hot water. But what happens when boiling water erupts from a volcano? When a volcano erupts under the water, it creates a massive explosion. The hot lava and gases shoot upwards and outwards, creating a huge cloud of ash and debris. This eruption can cause major earthquakes, tsunamis, and even level entire islands. But what effect does it have on the life surrounding it? Well, it depends on where you're looking. Areas directly affected by the eruption are unlikely to support life after a volcanic eruption. The heat, gases, and debris can destroy entire ecosystems in an instant. But further away from the eruption, things can be a little different. In the days and weeks following an underwater volcanic eruption, there can be a huge increase in the amount of food available. The ash and debris carried by the currents can bring with it a large amount of nutrients that are essential for life. These nutrients can cause massive algal blooms, which can in turn lead to an increase in the numbers of other organisms. Many fish species feed on algae, so an increase in algae can mean an increase in fish. However, this doesn't last forever. As the initial wave of nutrient-rich water subsides, the ecosystem is left in a state of recovery. Some species are better suited to surviving during this time than others. These species tend to be small and fast-growing. For example, the copepod is a small crustacean that is often a key part of the zooplankton. Zooplankton are drifting animals that form the basis of many marine food webs. Copepods are well suited to surviving in the aftermath of a volcanic eruption due to their small size and rapid life cycle. They are able to reproduce quickly and take advantage of the new food sources that appear in the water. Similarly, the psyllium is a type of single-celled organism that can also thrive in the aftermath of a volcanic eruption. These organisms are well suited to surviving in harsh environments due to their simple body plan and ability to reproduce quickly. But while life can recover after an underwater volcanic eruption, it's unlikely that it will ever return to what it was before. Volcanic eruptions can have long-lasting effects on the environment, causing changes in water temperature, chemistry, and light penetration. These changes can alter the balance of the ecosystem and lead to the loss of some species and the proliferation of others. For example, an increase in volcanic activity near hydrothermal vents can change the temperature and chemistry of the surrounding water, affecting the types of bacteria and other organisms that can survive there. So while life may find a way to survive in the most extreme environments, it's constantly changing and adapting to the world around it. So, although some life may exist in boiling hot water, what about fire itself? Watch this video to find out why fire can't spread underwater. Thanks for watching. Do you know any obscure science facts? Share them with us in the comments below.